Uh, Hi guys, am I audible? Am I audible? If you guys can hear me, if you any of you could, just kindly press a yes on YouTube. Kindly press a yes on YouTube. Yeah, I think yes, folks, you can hear me. So yes, folks, good morning. My name is Nikhil Kumar Jha, and I am from GDG Bangalore. I am currently a co-organizer at GDG Bangalore. So I want to welcome you all to today's event. And before starting the event, I wish that all of you are doing good and that you guys are staying safe and you guys are taking all necessary precautions in this current times. So first of all, I would like you to introduce you to today's topic and then followed by a brief introduction about a speaker. And then a speaker, Abhishek, would be taking over for today's event. So today the topic that we are going to cover is called taking deep learning from development to production with Kubeflow. So I'll get into it, but before I get into it, let me first take the opportunity to introduce Abhishek to you guys. So this is Abhishek Kumar with us. We have Abhishek Kumar with us here. Abhishek, if you could just say hello to our audience. So
Hey guys.
yeah, so Abhishek is a Google developer expert for machine learning, and he holds a master's degree in data science from the University of California, Berkeley, UC Berkeley. And Abhishek has also been featured in the top 40 under 40 data scientists list in 2019. Abhishek is currently working as a data science manager at Publicis Sapient, and Abhishek has authored a number of courses online courses. The recent one being building end-to-end machine learning workflows with Kubeflow. So I would just want to give you a brief introduction about today's event, after which Abhishek would be taking over. So you might have a lot of you might have built machine learning and deep learning models already, but most of that models that you have built, including are usually you usually build it out of your own curiosity, or you build it as part of some online course or some online course that you do or some online project that you do. But in today's session, Abhishek will be teaching us how can you build those models, and then you can take that right from the development stage to the production stage using Kubeflow. Now over to Abhishek. Without further ado, I'd like to hand over the session to Abhishek, and Abhishek would be taking it from here. In the meantime, if you guys have any doubts, please feel free to post it in the Q&A session. If you feel that we are going fast or if you're going too slow, you can just post it on YouTube, and we'll be taking it from there. And you can tweet on Twitter using hashtag GDGBLR @GDGBLR. That would be all from me. Thank you so much. Over to Abhishek. Abhishek.
Hey guys. Can you hear me? Am I audible? Can you just confirm? Can you hear me? Hello. Can you hear me?
Abhishek, I think they can hear you.
All right.
Just,
Cool.
I think
Thank you.
there's some lag. So if you could just give them 2 seconds, I think. Yeah, Abhishek, we're good to go. The audience can hear you.
Sure. All right.
That's
All right, guys. So first of all, thanks a lot, everyone, for joining, and really appreciated the time that you have been put in, especially on the weekends. And in today's talk, let me share my screen, and then maybe we can get started. All right. So hope my screen is visible. Let me just put into presentation mode. All right. So hope you can see the screen and the presentation.
yes. Yes, Abhishek. I think they can. Yes, they can see your screen. They can see your presentation.
All right.
It's perfect. It's perfect.
All right, guys. So yeah, today's topic is taking machine learning or deep learning from development to production. And I'm hopeful that probably folks who are there on the call are definitely from the ML and DL background, and they have been developing lots of machine learning and great models. But I would like to take you to the journey and talk about that what it takes to go from development world to production world. And why do we need that? What are the challenges associated with that? And what are the solutions that you can look into to solve and mitigate some of those problems? So I think this is a brief introduction. Thanks a lot, Nikhil, for sharing the introduction. So I'll just skip it. But before we get into, probably I just want to capture, because this is obviously a virtual event, I would definitely like to capture some of the probably what are expectations, as well as how much you are involved into the model productionization. That will give me that to what level of details that I need to go. So I have probably a link. If you can just open this link, that would be great. So just go to menti.com, and then you can use the code 631013. And if you can just hope you are able to see that. And I have just a quick question for you. And the question is that have you productionized machine learning or deep learning models? If you're comfortable with it, you can probably put that. If you've never tried that, completely fine. And we'll go through some of the ways how we can do that. If you feel it is very complex, probably that's also fine. We'll see that what are the challenges associated with that. And if you feel that is not my job, that's also fine. Cool. So I'll just wait.
Abhishek, I've just put I'm sorry to interrupt you, Abhishek. I've just put a link of this website and the code in the comment section. So I think the the audience can go through it. And if any of you would need the code again, in case you're joining late, it's there in the comment section, or you can just tell me. I can just put it there again. Thank you, Abhishek. Thank you.
Cool. So I'll give it a minute so that people can actually vote.
Guys, please do vote in the comment section. Just a yes or a no would also do good, so that we have a understanding of what you would need, and we can make the session more useful and more productive for you. So I would really appreciate if you guys could just put in a yes or a no, and if you guys could log into the session and use the following code.
Yeah. So just go to menti.com and then use the code 631013.
Yes, I think a few of them are telling yes.
Okay. So I just.
Yeah. So I think, Abhishek, if you could just, for those who don't know, who are not feeling so comfortable in telling a no or a yes, if you could just go through it in like a few minutes, like so that everybody can be on the same platform while proceeding. Everybody can be on the same page. Thank you. Guys, I hope all of you have logged into menti.com and used the code 631013.
Yeah. And I have one more quick question, and this will help me to probably know that probably how much of detail that I need to go. And this question is that how much comfortable you are with Docker and Kubernetes. And we'll be talking about them a lot in today's session. So probably just use that.
If you guys are familiar with Docker and Kubernetes, I mean, if you guys could just tell a yes or no again, I mean, that would be That would be good. So we're doing this in order to just to make sure that all of us are on the same page while doing this event, so that none of our efforts and our time goes into does not make it productive. We want to make it as productive as possible for everyone. So I mean, if you are comfortable with Docker and Kubernetes, Kubernetes and Docker. So, so I think Abhishek, in the meantime, while they're
Yeah,
voting, I think a few of them are telling us they don't have idea of Docker and
that's fine.
Kubernetes. So if you could just give them a quick intro about Docker
Yeah.
and Kubernetes on like what do they actually do for
Yeah,
this event?
so we'll be in fact covering Docker and Kubernetes to some extent. So that
Okay.
probably I'll give as a part of the presentation, because the reason I just asked this question is so that I can understand to what level of details that I can go. And don't worry if you don't know about it, and that's completely fine. The idea is that by the end of today's session, and then you will have some understanding of both and why they are needed, especially for data scientists, as well as we'll talk about that how they can actually solve some of the key challenges in the world of model productionizations and how industries actually use them for building large scale pipelines. So even if you don't know about it, that's completely fine, and then you're good to go for today's session, and we'll cover a problem and give the background about it. Okay. So probably I have the results with me, and in general, I just probably I'll share without sharing the actual voting results. Is that lots of folks actually have used it as well, but there are lots of folks who have not heard about it. And there are few folks who have actually heard about it but have not used it, and that's completely fine. And then we'll cover that probably what exactly it is and why do you need it at the first place. Okay, so thanks a lot. Really appreciate folks probably for sharing your votes, and that helped me to probably gauge that probably at what level that we can go into the today's session. All right, so probably I'll move ahead. But before I go ahead, and probably if you're looking for like more detailed course, I have actually also authored a very detailed course on it that is available on Pool site. It's a roughly 4.5 hour course, and that talks about all of the fundamentals as well as how you can build a production grade machine learning and deep learning workflows. And the link is there on the screen, and probably you can use the same if you want to. Anyways. So coming back, right? So why we are having the session today, and all of us who know work in the field of AI and machine learning, it's sure that probably know that AI is something which is definitely changing the entire world. Probably we also call that as the software engine powering the industry revolution 4.0. All great things, right? And probably we see the applications of machine learning and deep learning all around us, be it the recommendation engines, video recommendations, personal assistants, or enterprises using it for predicting risks, building personalized medicines, or even detecting fraud. It's everywhere. Uh, and in fact, if I go back, probably the money that is being put into this field, as per the Gartner's report, roughly 3.9 trillion business value will be created by ANML in by 2022, and roughly 77 billion dollar has been spent into building these AI systems. All great stuff, right? But let's look into the flip side of it. This is just a survey done by O'Reilly probably last couple of years now. And here actually they asked the respondents that how much the adoption is there in your enterprise. And then if you see the results, right, so you have only 15% of respondents actually told that they're using models into productionization in production for 5+ years, and almost 50% are simply exploring. So what that means is they are building some POCs. They are probably okay, yeah, this is great and this might help, but they are not able to leverage the full potential of an AI ML. Now, why this is challenging, and this is the reason I want all of you folks, probably if you're involved into this field, to understand the challenges associated with it. And I'll just put one line, which is that 87% of the AI projects never make it to production. So what does it mean? It means is that all of the great efforts that we have been putting into all the great models, the fancy things that we have been doing, actually never cut that cut to the chase, and you know never actually use all of these models into production. And what are the key reasons behind that? So if you look into that, most of the probably the data scientists, they feel as that research and evaluation is the only thing, right? But it's actually not the case. If you look into that, if you compare what happens in a research and evaluation phase with the production phase, in a typical research and evaluation phase, you can think that as a Kaggle competition as well, or probably any other probably POC that you might be developing, where you might have some data sets, you might be doing a manual extraction, you might have are doing some kind of in-memory analysis, maybe using pandas, TensorFlow visualizations and whatnot. And then you might have some small scale training, which is probably working on a subset of the data set, and then you evaluate your results and how great it is. But if you probably move from a research and evaluation phase to a production phase, and that's where the problem starts occurring, because in a production phase, you might not have this manual extraction as an option, and you might have data that is coming in real time, or it could be a batch ingestion. It could be multiple data sources which are coming, and probably your data itself is pretty huge. So that means even your data processing, which you were doing or probably doing some analysis on a small scale, maybe on a machine or laptop, it might not work out, and then you might have to do that at scale. Same thing goes even for the training process. Now, a single node execution, single node training might not be sufficient. So that means you need to look into ways that how you can perform large scale training that might include, let's say, spatial hardware such as multiple GPUs, or in fact multiple node and multiple GPUs. And then once you have built the model, the journey doesn't stop there. Probably you create one model version, and then eventually you create multiple model versions. Typically in organizations may have hundreds to thousands of models running in production. And then once you have these models running in production, then you might be doing what you call as real-time inferences. And then you might be storing your model performance metrics and how well they are, because you might have to retrain those models based on the need requirement. So as you can see that when you move from a research to a production phase, there are lots of extra components, and the workflows becomes as complex as it can be. So some of the key challenges and is that, first of all, how do you deal with scale? How do you even build such complex workflows, which might not be easy tasks to build? Because typically what we do in, let's say, in a research and evaluation, there is a script, and then we write all of the steps into one script, and we are fine. But in a production phase, you might have data coming from multiple systems, and then you want to do an automation and whatnot. The other challenge comes from collaboration and reproducibility, because you might not be working alone, right? You might be working in a team where probably multiple data scientists, ML engineers, data analysts, and different people come with a different skill sets. And one of the biggest challenge that comes what you call as reproducibility. So what does it mean is that somebody asks, you know what, you built a model probably a week back or probably last month. Can you just reproduce the same, right? How do you go about maintaining the experiments that you are doing? How do you track all of the experiments? How do you in fact monitor the performance of your models or your training process and how good they are, all of that? So not only model performance, you also need to look into some of the what you call as a non-functional requirement, such as latencies. Now, suppose that you built a great model, but it is giving a prediction, it is taking enough time that it is not usable, because it can take a hit on the user experience. So that's a reason that probably not only some of the key functional requirement you would like to measure, but also some of the non-functional requirement. So if you see that model development, which typically we focus a lot, but that is only one part of the puzzle. In fact, probably this might change for case to case, but in general, you can see that if you're developing a model and evaluating locally with a team of 1 to 2 data scientists or analysts, they can finish the job into 1 to 2 weeks, right? Or it could be 3 and 4 based on the problem statement. But if you go from the journey of probably local development to actually productionization, which might include multiple other activities or multiple steps, and that can take months, with large team of developers, data scientists, data engineers, DevOps, and whatnot. because you might have to package your model. You might have to look into how do you scale or train on a large data set. How do you in fact tune your model, which could be an hyperparameter tuning, but now instead of working on a smaller subset of the data, you might have a huge data set. How do you even perform hyperparameter tuning on that case? How do you leverage GPUs for that? And once you have probably have the model, how do you monitor the performance? How do you version them? How do you identify, apply certain security policies on top of it? And then how do you in fact automate the entire process? Because while you can do a manual probably process, but in a typical organization, we are actually who want to use these systems into production, they cannot rely on manual steps, right? They have to have automation in process. For example, continuous integration and continuous deployment, which is a very popular term in enterprises. You might also might want to do a rolling upgrade. So that means suppose that somebody has built a newer model, you want to switch to the newer model, but you don't want to probably switch the entire one. You want to test that whether probably what you call as a canary releases, which is that I pass on only, let's say, 10% of the traffic to the newer model and gauge the performance on that. And then obviously you can also look into A/B test to measure the effect, right? So as you can see that there are lots of moving pieces, and there is an entire journey that one has to cover. So if it take a step back, and even if probably if you are a data scientist, I'm sure that you will agree that we have to deal with a lot of things. We have to deal with environment variability, right? Because people have probably different skill sets. Someone are more comfortable in Python, some are developers, someone are using Scala, maybe a Julia, fancy languages, and then you might be dealing with multiple frameworks, be it Spark, TensorFlow, PyTorch, Chainer, MXNet, and there's so many things out there. And then probably how do you work in a collaborative fashion? How do you scale in production? So these are some of the key challenges which are associated with that. So what is the key problem? So first of all, if you say that setting up a ML stack and pipeline is incredibly hard. It's a fact. But if you have to probably build a production grade pipeline, that is harder. And God forbid, if somebody asks you to build a pipeline, an ML pipeline, which actually uses a multi-cloud, which could be probably multiple clouds, or in fact, it could be a hybrid solution, that is really challenging. And some of the key challenges actually leads to some of the key problems. I'll talk through some of the problems, which are that because of all of this complexity, companies or organizations are not able to update their models regularly. Let's say that they are actually afraid of refreshing their models because they feel they're not sure what will happen. It's a manual process. They're not able to reproduce the results. And initially they try to apply the traditional software development workflows and try to apply and slap it on the machine learning workflows, but that doesn't work seamlessly. And that means is that your process is slow. It will not work out in a way that it is expected, and eventually you will not get the return on investment on the great work that you're doing. So the bigger story is that when we focus as a data scientist, and probably I might myself in the same category, when we focus on probably a model, you see that, okay, building a model is the important thing, but it's not, because building a model is just one step. And this was one of the part of the paper that was covered by the Google, which covered like technical debts. And it talks about that what are the 9 yards that you need to cover before you actually leverage any models into production. Right. So you have to build the entire pipeline from your ingestion to your data validation, data splitting. You might have to do that at scale, and then you have to roll out your model. You have to serve your model, then you have to monitor the performance and all of that we just talked about. So not only this, so if you look into some of the other challenges, so let's say that if you're doing an experimentation. Now, for us, what we do is, okay, let's assume that you are using a certain framework. Let's say you're using a TensorFlow framework. And but underlying there are other components that probably you might not be thinking, but eventually you might have to. For example, where you're running your code. Are you using a GPU or not? Which operating system that you're using? Do you have the right runtime? Is it a Python 2, Python 3, whatnot? What is the underlying storage layer? Probably are you using something which is fast or probably an SGD? And then what are the probably models that you will be building? So it's the entire stack that one has to be aware of. And if you go from look into that, probably all of the steps that we have, which is the entire data ingestions to from development to productionization. If you move from an experimentation phase, which could be your machine, which could be your laptop, and then move into a training or probably even in the cloud, it becomes a very challenging task because different environments might be different. How do you propagate your code or the scripts or anything that you have written from your development machine to different environments? So one of the component, and probably that is heavily used, what we call as containerization. We call that as a Docker is obviously one of the most popular containerization choices, but there are others. But probably for the course for today's session, we'll use the Docker as well as containers interchangeably. But in general, you can think Docker as something which can help data scientists to be more productive. And they can enable reproducible as well as collaborative data science. So even if you're not using it right now, I'm sure that you should definitely explore that, and it will actually help into you. Even if you're probably working on a small machine alone, you're not into an organization, you're even a student, it will like greatly help probably in your actually data science journey. So what exactly is container? Those who have used it, great. Those who have not used it, completely fine. You can think containers just as a box, right? Probably a big box where you put your code, which itself could be your training code, evaluation code, or anything that you do. And then you also take your configuration, let's say that which environment that you're running or any other configuration that you feel it is required for that code to run, and then dependency. So when I call dependency, this means as environmental dependency. So for example, you have built a code which runs on Python 3 and which uses a specific version of TensorFlow. Let's say that you are using TensorFlow 2.1 and it will not work into TensorFlow 1.x. So you need to mark that what are the dependencies. You might have some other requirements. So apart from TensorFlow, you might be using other packages. Let's say that you're using TensorFlow datasets or probably any other thing. So you can put all of your dependencies and then combine all of the code configuration as well as dependencies into a box, what we call as a container. And then idea is that these containers can actually run on any environment. So that is the beauty. So that means is if your containers are working on a local machine, you can be rest assured that it can work even on the cloud or probably anybody's your friend's machine or whatnot. So that's the beauty of probably Docker. So it provides lots of things, and the biggest benefit is it provides an environment isolations. I'm sure that you might have encountered, you know what, I have a TensorFlow 2 version. The code that you have given to me, it actually uses TensorFlow 1 and it's breaking. Right? So I'm probably that's why I'm not able to use it. I'm not going to update my TensorFlow version because probably that will break all of my previous code. So there are lots of challenges that data scientists get into. One way of doing it, obviously, you might have used virtual environments, and obviously that is one way of looking at it. But virtual environments only solve the problem of Python dependencies. What about other dependencies? What about OS dependencies? You might have worked on probably image recognitions problems, or if you used OpenCV, you know that OpenCV, installing OpenCV itself is a challenging task, and there are lots of lower level OS level tweaking that you might have to do, right? So all of that becomes a very tricky task. And then if you have to move your code probably from one machine to another machine or one environment to another environment, it becomes a very challenging task. So that is your environment isolation Docker provides out of the box. It also provides reproducibility. So that means if your code is working on in a container, that means it can run anywhere. So that means you can reproduce the results again and again without being worried about environment or anything else. Documentation, which actually comes by default. So what does it mean? Documentation means is when you are actually building, and we'll see a couple of examples probably in the demo, but when you are building a containers, you're actually providing the entire dependencies in a textual format. So basically you create what you call as a Docker file. You can think that as a blueprint. And that means is you're actually documenting all of the required dependencies inside the code itself. That also makes it portable. So that means is that if the same dependencies can be replicated into another environment, you can port that code. Another best benefit is what you call as a community benefit. So what does it mean is if you search for, okay, I want to do some activity, I'm sure that you'll search for Docker, you will find a Docker image somebody might have already created for you, right? So for example, you might find Docker images for, let's say if you want to use GPUs and GPUs with TensorFlow, with all the CUDA and everything pre-configured, and you can directly leverage that. You can build on top of it. And we'll see a couple of examples in the demo as well. So that was about Docker. So we see that Docker obviously great. It solves lots of challenges. It solves all of the environment isolations. And but when you move from one Docker container, which is think that as a one box, and that thing probably in enterprise world where it has to scale. So that means is now instead of one Docker container, you might need probably multiple Docker containers. How do you deal with that? How do you probably build a system where you can combine multiple boxes to solve a problem? I'll give you example. So for example, let's say that you're building a machine learning application. There's a front end, which is an UI application. Either it could be a mobile application, web UI. For simplicity, let's think that as a web UI. Which you are using for building image recognition problem, right? Now, that means is that there's an UI, and then the UI actually you upload your images, and then in the backend it should call an API, which is nothing but trained model is exposed as an API. And then once you upload and once you click predict, and it kind of takes the models and make the prediction. Now, think that as probably multiple boxes. One box is for UI. One box is for your API itself. And then you might have other boxes which you are using for some other purposes. And then you want to scale the system. So since initially you deployed and everything was great, and you had, let's say, 10 users using that system. And since you have built a great application, probably millions of users poured in, and then you know what, I want to use the same application, and suddenly your application crashes because you have not built for that. So what you do is, you know what, I can manually add a couple of more containers, but suddenly that leads to the problem is, that probably you have, how do you configure different containers running on multiple machines? How do you probably do a load balancing? So basically there are lots of other challenges that comes in, and that's where Kubernetes comes into the picture. So again, you have not heard about it, that's fine. You can think that probably Kubernetes is something which will make the life easy if you're working with containers, and think that as a scaled version if you want to probably do anything about with containers in an enterprise setting, or it's a large scale, you might have to leverage Kubernetes. So essentially what it provides an abstraction so that you focus on the application. You focus on something which can probably, you don't have to bother about how do I scale, how do I probably if there is a machine going down, how do I look into the resiliency and all of that. So it kind of abstracts away all of those, and so that you focus on an application. The other thing that it gives what you call as a declarative definition. So what does it mean, declarative? So declarative definition means that you say that I want 10 copies of my application, and no matter what happens, let's say even if machine went down, I have deployed into 5 machines, even if one machine went down, it's the task of Kubernetes to probably spin up a new machine, create a copy of your application, and make sure that you have 10 replicas. You can also do probably an auto scaling. So that means you can set it, okay, I want probably 5 nodes to probably 500 nodes, and it can go automatically scale up. It can also scale down. So that means you don't have to probably incur extra cost because you have over provisioned your system, right? It can also help you into a lot of other things, which is like updates. You can update your models, update your applications. It also provides what you call as a service discovery. Because typically what happens in enterprises or in a bigger large applications, there there will be other applications. It's not that probably you have only one system. You might have multiple APIs, one API for doing, let's say, some NLP stuff, one API doing some recommendation engine, one API doing some kind of an image recognition. And then you kind of build your application, something kind of a microservice architecture, and you combine multiple pieces to build your application. What Kubernetes also allows is to probably discover what are different services, and then you can combine them, you can route them. And obviously there are lots of other challenging things that complicated things that you can try it out. Now, so far what we discussed was Docker, great. Kubernetes is also awesome. But actually, if you go probably beyond that and come back to the problem statement that we had, which is that you have to look into from a typical machine learning or deep learning workflow, from a development to productionization, we have to go through all of the steps, right? So how Docker and containers or Kubernetes fits into the overall ecosystem? So what exactly it happens is all of the underlying component, which is the OS level and dependencies and everything, will be handled by Kubernetes, right? So that you don't have to bother about it. And also that means you can actually run everywhere. So that means you don't have to bother about whether you're running on cloud or probably a GCP, on an AWS, on Azure cloud, or you're running on-prem. So it abstracts away all of those layers. But what about the probably other stuffs, right? So so far we know that, okay, you know what, Kubernetes is great. We know that machine learning, you want to run on Kubernetes because it gives you all of the flexibility. But as you can see that even if before you use that, you have to probably be expert into lots of things, right? You need to know containers, packaging, how to probably work with service endpoints, persistent volumes, scaling, immutable deployments, and blah, blah, blah. There are lots of things, right? And those could be overwhelming at times, right? Now, so what is the solution then? So we know that all the great things that comes with Docker and Kubernetes, but it's also challenging because there are lots of moving pieces. How do I probably leverage and work around that? And that's where Kubeflow comes to the picture, right? So what Kubeflow essentially provides is an abstraction, think that as an abstraction layer, which kind of takes care of all of the heavy lifting, and then it abstracts away lots of underlying details so that you don't have to worry about all of those. You don't have to be a Kubernetes expert into at least to use that initially, right? In fact, we'll get into the details. So there are a couple of core principles, right, which Kubeflow has a mission. One is that it gives you what you call as low barrier of entry. So what does it mean is, let's say that you are a data scientist. You don't know probably much about Kubernetes. You don't know much about containers, and that's fine. You can directly leverage some of the off-the-shelf features which are available by Kubeflow, and then you can directly use that. But it also gives what you call as a high ceiling. What does it mean is that, let's say that if you want to do very complex customization, and then you have a requirement of very complex machine learning workflows, especially in the production environment, it gives you all those nuts and bolts, which you can actually configure and probably use that to tweak to your requirement. So in general, if you've not heard of Kubeflow, here is what it is. It makes probably it easy for everyone to develop, deploy, and manage portable and distributed machine learning on Kubernetes, right? So let's break this apart, right? So we probably see that there are a lot of words here. So first of all, Kubernetes, we already discussed what exactly is Kubernetes, right? And the idea is that it's the same one particular environment which allows you to develop your entire machine learning workflow, right from your initial exploration, initial experimentation, and you can track and all of those experiments to more complicated stuff. And then you can actually even deploy your models. And then you can in fact manage it. What do you mean by manage it? Means that you can look into auto scaling. You can look into all of the fancy graphs and see that what is the latency that is going on. I want to do a canary release. I want to run an A/B test. All of that it can provide. So what exactly it is? So if you think Kubeflow is just like any other TensorFlow or probably PyTorch, it's actually not. You can you can think this as a toolkit, right? You can think that as a curated toolkit where Kubeflow community has done is they had kind of brought together all of the compatible tools and artifacts that can work together, right? And probably in a seamless fashion, and then you can use that to build a production grade machine learning and deep learning applications. So probably off the shelf, and I will quickly get into the demo, but it gives you, first of all, it gives you what I call a typical notebook kind of environment, but obviously it comes with some other things as well, some more batteries charged, and we'll see some of the benefits of using Kubeflow notebook servers. So it gives you probably some of the like backend storage. You can work with the team in a collaborative fashion. You can have a centralized storage where you can keep your artifacts and data. You can actually sync across multiple users and all of the fancy things you can try it out. It gives you training, which is not only on a single node. You can look into multi-node, multi-GPU training, and we'll see quick examples around that. There are multiple frameworks it provides for serving, which means is how we can take a trained model and expose that maybe as REST API, how you can expose that as a gRPC endpoint if you have low latency requirements, and you can do lots of fancy stuff. It also provides what you call as a Kubeflow pipelines, and we'll see again examples of that. And you can build very complicated pipelines, which might involve multiple components, multiple tasks, and you can schedule those pipelines. So you can build your entire CI/CD things around it. And then it also supports multiple other frameworks and integrations. So in general, some of the three core tenets of Kubeflow is it is supposed to be, or at least it provides what you call as a composable. So that means is you can actually combine all of your libraries of your choice. It doesn't restrict you. You need to use only TensorFlow, you need to use only PyTorch. You can use anything. You can use MXNet, you can use Chainer, whatever that it is. Any other, let's say scikit-learn, if you're not probably going for very fancy machine learning, deep learning algorithms. So you can leverage all of that and then probably combine them to build your solution. Again, it is a scalable, so it can automatically scale based on your number of users, which is using your system, or the workload size. When I say workload, it could be your training job, it could be your hyperparameter tuning job, and can automatically scale based on all of your requirement. It is completely portable. So that means you can work on a machine and then you can port into a public cloud. You can port into an on-prem setup as well. Because like I mentioned, is Kubeflow runs on top of Kubernetes, and Kubernetes is again an open source framework which you can run anywhere. So that means just by combining the power of these two, you can take all of your machine learning and deep learning workflows and then move from your laptops to probably a large scale cloud deployments in just a matter of clicks. So let's quickly go to some of the probably examples and actually show that what are the things, how you can start leveraging this, okay? So the first thing I believe that's the easiest way to get started with Kubeflow is obviously you can go to Kubeflow website, and again this is like this said is this is an open source framework started with from Google. So and then probably obviously eventually lots of other companies also started contributing, and you can probably follow some of the get started guides and then some of the details around it, right? And you can set it up. I'll not go to the details of how to set it up, but you can set it up on AWS, on Azure, on GCP. You can set it up on private cloud such as IBM Cloud. You can set it up on on-prem as well, on OpenShift. So there are multiple ways that you can set it up, the environment. And once you set it up, probably I have already set it up for me. So I'll quickly show that how it looks like. So let me just quickly get that. All right. So if you will set it up, your environment, and I just set it up just before today's session, you get what we call as a central dashboard. Now this is you don't have to always use that, but you can think that as a central dashboard to manage and probably kick off some pipelines. But obviously, a lot of things you can automate as well. If you want to do something, let's say locally, and you don't have any cloud, while obviously you can directly, let's say in GCP, you can set it up a free credit, $300 credit, and then get started with that. But you can also set it up locally. There will be certain restrictions, obviously, to the things that you can do. You can look into, so Minikf is one good example. So it kind of gives quick, and like we will be up and running in a few minutes. And then you can directly set it up on either on Linux machine, on Mac OS, or even on the Windows. So that could be one option. There are other options as well. For example, MicroKTS and Minikube. Again, this is a 2-hour session. I cannot cover everything, and I'm not expecting you to know everything. But at least just to give a heads up that in terms of in what direction I need to go, what are the areas I can explore. So this is the whole motive behind today's session. So I'll quickly talk through the first component, and we talk about in a typical development journey what happens. You start with probably notebooks, right? Because data scientists love notebooks, so why not? So you can actually set it up notebook servers. You might have used Jupyter Hub, and this is kind of managed some Jupyter Hub version itself, probably some more features. And you can set it up your own server, and I'll talk through how you can set it up. It's very easy. You can just give it a name, let's say my test, and then you can provide what is the image, right? So here is what your image we just talked about, Docker, right? So you can think that image is something which is self-sufficient, which contains all of the environment dependencies and everything is already baked in. And there are some pre-populated images which are already out there. For example, you want to use CPU of TensorFlow 2.1.0, or you can want to use GPUs, anything. Let's say that you want to use GPU, right? And you can set it up that how much requirement, let's say a CPU requirement, let's say I want to give a full CPU, I want to give 4 GB of RAM, and then you can set up what you call as a workspace volume. Now, you can think that as a storage layer, right, which is an underlying storage. And you can also mount that storage from what you call as a network file storage. And this is a very common practice, especially in enterprises. What you can do is you can set up probably, let's say there's a Google file store, right? And there you can have your own network file storage as well. But you can think that, okay, there is a central file storage. And then let's say there is a team of, let's say 10 data scientists or probably 50 data scientists, right? And you can actually configure the storage for them. So that means even if you destroy all of that, all of your work will be persisted. You can also share among users. So for example, in your team, let's say one particular user is great in, let's say, data exploration. They are like pandas expert or something expert. One team member is TensorFlow expert, right? And then you can actually sync your volumes, and you can actually share and work in a collaborative fashion. So all of fancy things you can try it out. You can also add the data volume. Suppose you might have data volume somewhere where you are storing your data sets, and you want to directly access it while you're training the models. And then you can have some other configuration. So for example, in this case, you can, let's say that all of your components are in the Google Cloud. So that means you are running, let's say your data is in Google Cloud Storage, or you want to have data into BigQuery or anything else, right? So you can connect with that. You can also specify GPUs. So you can have one GPU, you can have multiple GPUs. Currently, so far, it supports NVIDIA. So you can say that I want 2 GPUs, NVIDIA, and then you just simply click launch, and the notebook will be created for you, right? So I have created just probably one notebook just before the session. So for example, I created my custom notebook. I was also creating one more GPU, but obviously it is taking more time. So in the custom notebook, I have also used a custom image, and I'll show that how quickly you can make that. And once you will build this notebook, you can actually connect to the notebook, and it might seem very familiar to you. So this is very standard, your Jupyter notebook kind of an environment, right? You can also have lab, so you can just switch from tree to lab, and you will have your Jupyter Lab if you prefer Jupyter Lab kind of an environment. Okay, so so here is my Jupyter node, and then you can upload your notebooks to it. I have just uploaded one notebook just before that to a session, and then we'll quickly go through it, right? And again, in today's session, it's not about specific model, a specific, let's say you can be as fancy as possible. You can make very complicated models, but idea for today's session is just to give you flavor in terms of what does it take to move from a development to productionizations, what are the different things that you can do, and how this environment, Kubeflow environment, actually helps you, right? So I will come to the notebook afterwards. I'll just quickly show some of the other features which might be useful for you. And one good feature which is normally very popularly being used, what we call as manage contributors. So you can think that as, let's say that you have probably a team members. Let's say you have team members, 5, 6 team members, and you want to get someone else to review your code, or probably someone else to work along with you. All you have to do is just probably add their email ID, right? So probably you can add probably, let's say, user one, and you can call, you can probably put that. Obviously, this user doesn't exist, but you can do all sorts of things, right? And you can add multiple users. And once you have done that, you can actually, other people can also access your environment, and they can probably work on your notebook. You can also share code and anything that you can try it out. So before we get into probably an actual notebook and talk through some of the other aspects, probably any questions so far? I can take that.
Yes, Abhishek. There are a few questions. I think Nishant will be asking the questions.
Sure.
Nishant, can you hear me? Nishant? I think, yeah, I think Nishant is picking up the questions. Just 1 second.
Sure.
So far, Abhishek, it's been very amazing with the event. I mean, I've personally enjoyed it a lot, and I think the comments are also in that's what the comments also say. I think, yeah, Nishant is audible now. Yeah. Yeah, yes, Nishant. If you could just take up the questions that we have till now. Yeah. So Abhishek, in the meantime, while Nishant takes up the questions, how have you personally found Kubeflow to be like with your personal experience? You know, working with Kubeflow, how have you found it? What's your personal experience been?
Yeah, so we have been using, so because obviously as a company we obviously work with lots of clients, big clients, right? So that means large organizations with huge user bases, and probably millions of users hitting the systems. So that means for us, probably we need to definitely look for an option that how to work on that large scale solutions. So obviously we had to look for different options, and we kind of explored multiple options. So Kubeflow is one, and there are other options you can look into, and there are pros and cons of multiple approaches. So far, I think the journey with Kubeflow has been great. We have made lots of tweaks as well. In fact, some of our team members are also Kubeflow contributors and who have helped to shape this as well. And we work very closely with probably other members in the community and see that probably what are the things that we need. But in general, if you look from probably the workflow management perspective, it kind of ticks most of the boxes, if not all, but probably most of the boxes. I'm sure that if this is also a growing field and probably growing framework, and just like any other framework, it will grow. But so far, I think it's been great.
Yeah. So far, it's been great. Thank you, Abhishek. Thank you, Nishant.
Yes. So the idea about, I believe that was a question for containers. So this mean is that, or probably if you're working on a containers, you can actually develop anywhere and deploy anywhere. That's the whole principle behind that. Obviously, there are other challenges when you work into a productionization system, because you might have to tweak certain parameters. You might have entire workflow, and then those could be your configuration parameter. But as long as you have built the right workflows, it works flawlessly everywhere. Right. So if that answers your question. Right. So I will come to probably more complicated things. Probably let me just quickly share. We will build, in fact, a common, probably next an hour, complicated pipeline. Well, I'll quickly show you probably some of the pipelines examples, right? Just to give you a flavor, right? So for example, this is one of the pipeline, which is actually built with TFX, right? And you can have your custom one as well. But as you can see that this particular pipeline has multiple components, right? From your data generation to data validation, to data transformation, to your data training, and then you can have your pusher, which actually updates a model. But the idea is that you can build as complicated pipelines, as many components as you want, and it works probably out of the box.
Thanks, Abhishek. Next question is from Balakrishna. He's asking, could you please let me know if Kubeflow is deployed on an EC2 instance? And could it
Okay.
also be deployed locally on one's Mac?
Right. So, like I mentioned, is you can always set it up on one machine, which is you can think that as a local setup. You can multiple options. You can set it up either using minikf. You have options like microktas. You have your minikube. You can set it up all of that, so you can play with it. But obviously, the biggest feature, obviously, you can leverage once you deploy on a Kubernetes cluster. Now, Kubernetes cluster can be deployed everywhere. Right? It can be deployed in any cloud. It can deploy it on-prem. If you're working in AWS environment, you can set up your AWS Kubernetes engine, and then you can deploy on top of it. I'm not sure if you're meant for EC2 instance is just one machine, but you typically deploy on a Kubernetes cluster so that you don't have to bother about auto scaling and all of that bit, right?
Thanks, Abhishek. Next question is from Abhinav. Can you please share some light on roadmap of deep learning for self-taught developers?
Yeah, so I believe this is slightly different from the probably today's session, but I think for and one of the key takeaway that I want probably most of the folks who are there on the call is that I'm obviously a big fan of all the fancy algorithms, right? And you can always look into that, right? But also focus on that how these algorithms, how these models actually work in a setting where it can be used. And one of the things that is happening in today's world, especially in the field of machine learning and deep learning, is that ease of productionization. So a lot of probably work is happening is how we can get your trained model out and then probably apply it in different contexts, especially if you're building, let's say, an NLP pipeline or probably an image recognition pipeline and using any new fancy, let's say, new GPT-3 has come up, and then probably I want to leverage all of that, right? So how you can probably put together different blocks and then probably use that. And that's the reason this session, maybe if you can just get an idea that what are the things that it takes, right, to take thing which is you have developed on your laptop and to productionization and how to actually use it in a real application. That's where the core value lies.
Okay, so Nikhil, do we have time for a couple of more questions?
Any other question? I think you're speaking on.
Yeah, Nishant, your mic is on mute, I guess. Yes, Abhishek, I think Nishant's mic is on mute. Thank you
Yeah.
for answering that question.
So
Yeah,
Nikhil,
Nishant is on.
yeah, I was asking, like, do we have time for more
Yes.
questions?
Yeah,
Yeah, I can
Abhishek, would you
take
like to take
probably a
more
couple of
questions now?
more, and
Or?
maybe we'll start again.
Okay, sure.
Okay.
Sure. So, Anubhav is asking, how is it different from GKE or AKS where the vendor auto scales?
Right. So GKE and both AKS are the underlying layer, right? So Kubeflow actually is deployed on top of these, right? So the idea is that how do we leverage some of the, let's say, Kubernetes engine, which is already there either in AWS or Azure or AWS or on GCP, and then deploy on top of it. So we'll see that if I think, let me just quickly show. So what I had done here is when I deployed a Kubernetes, it actually created a GKE, essentially Google Kubernetes Engine cluster. Just taking a bit of time. So Bear with me. But the idea is that you deploy Kubeflow on a Kubernetes cluster, and the GKE and AKS, it actually provides an underlying layer, if that answers your question, while I just bring that up. Okay.
Yes, Abhishek.
Is there any question? I think I can read a couple of questions. Kubeflow supports any already developed pipeline or production. Well, you have to configure your pipeline so that it can run in a Kubeflow world. Essentially, it's nothing but just a bunch of containers, and we'll see an example as well, a demo. It's just an idea is that how we can take multiple components and containerize that, and then join them together to build a pipeline, right? So most of the pipelines are actually meant for that. But if it is not, you might have to containerize that, right? So if that is the question by, I think, Shantanu, Kubeflow supports any already developed pipeline. I think we answered that. Is there any storage limitation? Well, there is no storage limitation. So obviously it can be, you can attach, let's say, a persistent storage. If you are looking for that, you can attach your entire Google file store with terabytes and terabytes. You can also have local, let's say, a Kubernetes cluster. You can scale that up with, and you can increase from probably a couple of nodes to thousands and thousands of nodes. You can do all of that, right? And it will do all of that scaling and auto scaling automatically. And we'll see quick examples of that also. Okay, so hopefully we kind of will go into the details and probably run through a few examples, and I'm sure that probably it will answer some of the other questions that you might have.
Right. And for the audience and for our audience, I mean, we do know that you have more questions now, but I think Abhishek I think it would be good if Abhishek takes the next part of the session now, and then hopefully that would answer your questions in the meantime. And if not, we will take up those questions at the end of Abhishek's session. We'll again have a Q&A session. So guys, I hope you guys understand, and I think we are good to go now. In the meantime, please ask more questions. If you need any more clarifications, feel free to ask. Abhishek,
yeah,
are we good to go?
All right. Yeah. So I'll just take one example, right? And then we'll just quickly go through the journey, right? So like I mentioned, I have this notebook server, and in the notebook server, I just have a standard notebook, and we are using a very simple fashion MNES, just an hello world example. And I'll show that probably different steps and how you can actually take this, which is running in a notebook, do a large scale training, I'll do a large scale hyperparameter tuning, all of that bit in. We'll try it out. All right. So I'm just going through the notebook. I just quickly ran already. So this is a standard FASN MNIST. If you have worked on any kind of machine learning problem, I'm sure that you might have came across this. And then idea is not to go through a specific algorithm. The idea is just to cover the workflow, right? So I have a typical standard prepared data method. We kind of do a train test split, do probably creating a data set, building a model, which is again not very fancy model here. You can make as complicated as model as you want to. Just for the sake of simplicity, I've just kept it as simple as possible with a couple of, I think, with the convolutional layers, with max pooling, and then dense layers. We have 10 classes, and then we are compiling the model. And then we are also adding a few callbacks just to see that at every epoch, what is the loss accuracy and validation accuracy. And then once on the CPU training, and then you can actually do a standard training process, building model.fit. We all know that, so I will just skip this. And then once you have your model trained, you can do an evaluation. And you can see that it's not a good model, a very 76% accuracy, but that's fine, right? Because that's not at all the motive of the today's session, right? You can obviously add more layers, do fine tuning and whatnot. Okay. You can also look into TensorBoard. Obviously, in the time since we don't have the details, but you can actually run your TensorBoard and open that up in your from your Kubernetes directly, and I have shared the steps. Once you have the model, you can export this model. So for example, I'm just saving into H5 format, and then you can load the summary. You can do a standard export as well using the TF saved model, which will give you your graph as well as the checkpoints and assets. You can also look into their what you call as signature for serving purpose, and we'll be using that later on. So once you have the models exposed and trained and exported, you can also save it to GCS or probably any other location. Here in this case, I'm just storing on a Google Cloud Storage. So here is the function, small utility function, just simply stores on GCS. And if you remember that when we created a notebook server, we also added as add GCP credential. So that means is inside the notebook server, we have a Google application credential setup. So that means is from the notebook itself, you can actually and create your buckets and whatnot, upload files. So that is what I'm doing here. So I'm just creating another bucket. And inside that bucket, I'm just saving all of my exported models. So my models is saved into this particular location, export. So I can just go back and see. So I can go to my Google Cloud Platform, and I can click on storage, browser. And here is the folder, Google. So I'm just opening my Google Cloud Storage folder where I have saved the model just now. And here is the export folder, and inside the export folder, you can see your model objects, model artifacts, right? So 001, and then inside 001, we have the variables and saved model.pv, right? So pretty standard stuff. Now, so this is one step, right? I'm sure that probably this is very straightforward. We simply took ran a bunch of cells in the Jupyter notebook, but obviously you can go probably more fancy, right? And we'll see a couple of examples just now, right? Other things that it also provides, Kubeflow provides what you call as metadata tracking. So what does it mean, metadata tracking? So metadata, you can think that as data about the work that you are doing. That's what we call as a metadata. It's not actual model, it's not actual data, but it's about metadata about that. How this is useful. So think like this. Suppose you're working in a team, probably with 5 team members, right? And everybody is doing some kind of exploration, trying out different kind of an algorithms, and they are saving into probably some experiments, and they got certain kind of an accuracy and whatnot. So where do we put probably all of that artifacts, right, in a centralized location so that you can actually track all of your experiments? So that's where what you call as a metadata tracking component it comes, right? So it comes with your metadata package, and you can interact with it. So there is already a service which is running in a Kubeflow. When you set up Kubeflow, what you call as metadata service, it runs as a gRPC. And then you can actually create what you call as a workspace. You can think that as a big box. And then you can actually, for every run, when you could think that run as, let's say, I want to build a deep learning based model, right? We call that as a run. And then you want to do certain experimentation. So for example, we started with a convolution network with 32 filters, and then later on you want to switch to other filters. You want to switch to other kind of, let's say, normalization technique or initializer or optimizer and whatnot, right? So you can track any of those, right? All you have to do is just mention that what you want to track. You can put any kind of metadata information. So for example, I took a model, and who is the trainer? Let's say I am the owner, and I built a model of the certain type. I use certain model version. Obviously, you can take from a variable as well. This is just to show. And these are the hyperparameters that I used, and this is my model version. And then let's say that I store all of this model version. And then I use some kind of a data set. So for example, in a typical problem statement, what you might have is you might be doing some kind of feature engineering. You might be using some set of features to build your models. So you can track all of that as well. You can also store your metrics. So for example, what is your accuracy that you got? What is the loss that you got? And then other team members can also do that. The benefit of doing it is that one is that obviously you are storing a certain metadata information, and then you can also compare against, let's say that you might have a bigger team, right? And then you can also compare and probably filter. So there is an option, you go to central Kubeflow dashboard and go to artifact store, and it will store all of the metadata. This is just we just now created, and you can actually filter, right? So for example, you can look into any evaluation. So for example, this is the workspace. I can look into data. So this is the model that I built, and you can filter. Okay, so what are the models that I built with a certain performance, right? So you can build all sorts of things that you can try it out, right? So this is one feature. What you call it, this might be you can use during your development process. Now, typically, some of the companies, what they have done is they have also built a wrapper function of it, probably a more sophisticated UIs, where especially for a bigger team, where they can actually look into that. What are the people who are working on different use cases? What are the different models that they have made? How you can track all of that? But idea is that metadata component actually is exposed as an API. So that means you can build as sophisticated application on top of it. Don't have to rely on this particular UI. This is not that fancy though, right? So far what we have done is we are still in a notebook, and we are still probably working on one small machine which we configured with 4 GB RAM and 4 CPUs, right? But you can go beyond that, right? And we'll quickly show that how easy or how hard it is to build distributed training jobs, right? Well, let me quickly jump to probably, this is my VS Code environment, and let me show how easy or how hard it is. So this actually I'm covering some of the bits that I've already covered into my course. So probably I'm not going through all of the details, but I'll quickly show that how you can build that. All right. So for example, I'll show you that, let's say you want to build a distributed training job where I want to use not only one machine, but also multiple machines, and every machine may have GPUs as well. So you can build multi-GPUs, multi-node, multi-GPU, multi-worker strategies. So essentially your code, so let's example, this is my model.py, and the code may remain very similar. So what we just saw, which is exactly the same, which is we have the prepared data, we have the prepared data function, build model, get callbacks, all of this that we have just seen. I just added probably another pass argument so that we can pass all of these as an argument to the function. And the one thing that you can do, what Kubeflow provides, is what you call as a TF job, right? So what exactly a TF job is? So think that as, let's say, typical strategy. So so TensorFlow provides multiple distribution strategies, right? You might be aware of mirrored strategies and others. So where you might have, let's say, multiple machines probably working in sync together, and they might work on a smaller subset of the data and then train locally, and then probably have a central, let's say, parameter server, or they can sync among themselves. So here I'm just using one of the strategy, which is a multi-worker mirrored strategy. And you can say that how many replicas that you want, which could be, let's say I want five nodes, I want 10 nodes, and every node can have GPUs as well, right? The only change that I have made here is I just added, probably put all of the code of training process inside a scope with that strategy. And this strategy in this case is a multi-worker mirrored strategy. And then rest of the code exactly same. So where we are doing a model.fit, and then we are saving the model, what you call as a chief. Chief, you can think that as probably something where it is maintaining or orchestrating the entire training process. And then once you have the probably model saved, then we are doing an evaluation, and then we are exporting the model as well as to a GCS location, right? So this is what we are doing here. So very standard stuff. So this is my model.py. And then let's say that I want to create a container for this, because the whole idea behind containerization is that this code should be self-sufficient that you can run. So what we do is we build what you call as a Docker file. Now, this is how you build a Docker file. If you have not worked with Docker file, don't worry at all. This is very straightforward. You might have to learn about it later on, but I'll give you a brief flavor how it works out. So we know that there's a code which requires a Python, right? So what you can do is you can start from what you call as a base, right? Now, this base could be simply an operating system itself. For example, it could be an Ubuntu. So we say that I want to take Ubuntu-based machine and then install everything. Or you can take something which is already there. So for example, Python community has already created Python 3.7 base image. So that means this box is already configured with Python, right? So that means all you have to do is any other dependency that you have, you can simply put inside and then take your model, put inside that box, and you are done with it. So in this case, what we're doing is we are taking a requirements. So in our case, the requirements is what are the requirements? So we want a code which requires TensorFlow 2.1.0. We also want TensorFlow datasets because we are using TensorFlow datasets. Then we need Google Cloud Storage, since we are also interacting with Google Cloud, so that we can save the model inside the Google Cloud Storage. And then probably some of the other files if you have, right? And once you have that, what we're doing is saying that in a Docker file, think that as a blueprint, right? Which is take my requirement file and put inside the box. So anything which is after space, you can think that as a folder or some location inside the box. So we have a box of Python 3.7. Inside that box, put the requirements into that OPT folder and take from my current folder, which is my local machine. And then yeah, sorry, I think this line is repeated. And then you can simply install the requirements, standard pip install, right? And then we are also copying our other Python scripts, which is my model.py. There's a small helper function storage, which actually simply pushes data or models into cloud storage. We are just setting up its execution rights. And then we are saying is that this is my entry point. So this means that whenever you run the code, whenever you run the container, it should take the model.py and simply execute that. So this is what the entire Docker file blueprint it is, right? And what we have done here, we have taken all of our code, which in this case is environment model.py and storage.py, and taken all of the dependencies, which is Python 3, as well as everything which is mentioned in the requirements.txt, and then put that into a single box. Now, how do you use that? So I'll quickly show that how you can do that locally, and then I'll show that how you can do that on cloud. So let me just quickly copy path and just set it up, clear, and let me just navigate to the folder. And I have a bunch of steps already mentioned. So what we are doing is we are just creating what you call as every Docker image requires an image name. So we are saying that build an image name. So in this case, I'm just creating a small utility, which is nothing but an image name and image version. We are giving this some name. So you can think that as, like, so let me echo this. So this is my image name, first one, and I'll be saving into GCR. So GCR, you can think that as a Google Container Registry. So what we do is currently we are doing it locally. Once we have built this package, we push it into what I call as a registry that is available in the cloud. So there are public repo. So you might have heard about Docker Hub. So Docker Hub is your public repo. You can also have private repositories, and every cloud provides your private repository. In this case, we are using a Google Cloud Registry, but you can also use on AWS. You can also use on Azure, right? And then we are giving it a version, which is we are saying is take the latest version. So once you have that, what you do is you take the blueprint. So we are running a Docker build. So which means is build a container with the dot represent means that take the Docker file in my local folder and then run it. So this will build the entire Docker image. So, and once you have done that, you can actually run it either locally. So for example, here is the Docker run command. So while it is executing, I'll just walk you through the steps. So this is the Docker run, and this will run locally. You can also push this Docker image. So all you have to do is use docker.push, and docker.push will push the Docker image inside the Google Container Registry, right? Sorry, machine is slow. I think it is taking a bit time, but it will automatically populate. So while this is happening, I'll quickly walk it through that. So far, we are running it locally. But so in this case, yeah, it's done. So once this is done, let me just clear this and let me run it locally. So I'm doing a docker run command and passing the image name. So this is the image we just built, and this will try to run everything locally. So while this is running, I'll quickly show that how to build a distributed training job. Now, in the training job, what we use is what you call as a TF job, right? So in a Kubernetes world, if you worked on Kubernetes before, it is we use what you call as a YAML file, very standard way of defining what you want, right? So in this case, we are creating a TF job. We are giving some name. So let's say that create a training job, and then we are saying that is take two workers. So let's say I want, let's say two machines, I have two nodes. I want, let's say four nodes. I want five nodes, anything that I can do, right? So I can have as many workers as possible. And then you will have one chief always. And then chief is simply, you can think that as something who can orchestrate the entire process. And then what we need to do is we need to provide that, okay, take this take this one chief as well as two worker, and then run the training job, right? And then you can pass on all the required like parameters from the command line here. So you can say that where do you want to save your model, how many training steps that you want, how many learning rate that you have. You can see there are some additional things that I have to provide, because since we'll be interacting with our the Google Cloud Storage, so that's why it has to have a GCP credential so that it can save the model once it is trained. And once this is all you need to provide. So we need here in this case, we are saying that two workers and one chief. All right. And once it is done, then you can simply, let me just open the steps. So all you have to do is simply run kubectl apply. So kubectl is a command which actually being used to interact with Kubernetes, right? So we are saying that take whatever that we have mentioned in the training-gcs.yaml and then simply apply that. What it will do is it will create a training job for you, and then it will create a distributed training job, and then it will save the model once it is trained, right? So I'll not be doing it, but you can just try it out or search for TF job and it will be straightforward. Okay. So this is about the distributed training job, and you can see that it's not very complicated. All I have done is simply added a couple of lines inside my model.py, which was this strategy. The strategy, so simply I have added multi-worker mirrored strategy and then put all of my training code inside the strategy.scope, and Kubeflow will do all of the heavy lifting. It will populate that, it will automatically distribute the job on the worker, and then once the model is trained, it will save the model back. All right. So as you can see that my training job is also completed. So let me just pump this up so that it can see. All right. So this is about your training job. So I think my machine is incredibly slow. I don't know why. So I'm just canceling it for now. So I already have trained a model and saved it somewhere. So maybe what we can do is next step we can move what you call as hyperparameter tuning, right? So now hyperparameter tuning, you might have, let's say, you might be aware that, okay, hyperparameter tuning is something which is obviously one of the important steps, especially if you're building a machine learning or deep learning model. Now, what are the challenges? So think like this. Suppose you're working on a very large data set, and then you might have, let's say, a few parameters. Let's say that you have three parameters. You want to tweak the number of filters, or you want to tweak some learning rate and whatnot. And then for every combination of your hyperparameter, if it itself, let's say, it takes, let's say, 1 hour, right? And then if you have three parameters, for every three parameters, you have five combinations that you want to try it out. And suddenly you can see that if you're doing all of the steps in sequence, it will take ages to finish it up, right? So what this does is another framework that is available in Kubeflow, we call that as Katib, right? So let me just quickly show what Katib is, and we'll show that how it can be helpful. So let me just quickly minimize this. My bad. Sorry. Oh, I messed it up.
So Abhishek,
yeah.
While we are fixing this, I mean, if people want a more
Yeah.
if folks want a more deep insight into the into what you're doing right now, they can definitely go and take up the course that you have that you have authored, since
Yeah.
that would be like a more detailed there would be a more detailed explanation to each and everything. Unfortunately,
Yes.
the 2 hour time frame does not allow us to cover everything, and
Right.
we're just going through everything on the surface level. So
Sure.
they can do that.
Yeah.
Are you ready? Are you
Yeah,
ready?
yeah, I'm fine. So yeah, you
Sure.
can always do that. You can also look into your Kubeflow official documentation, and then you can follow some of the tutorials there as well. So probably have multiple options. There are a bunch of things available on YouTube and multiple places. So feel free to go through it. Everything is open source. You can want to take a course, you can take that as well. Anyways, so I'll just jump on to probably the Cative that I was discussing about, right? And in the interest of time, I'll just quickly walk through probably all the other stuffs. So Cative, what Cative is. Now Cative allows that, let me just open this up. Right. So it actually allows you to perform all of that hyperparameter tuning, and you can do that in a parallel, and you can specify that how many parallel experiments that you want. So that's one thing. Second thing that it also allows is that you don't have to bother about how to probably implement more complicated hyperparameter tuning process. For example, it supports standard grid and random search, but it also provides hyperband, it provides Bayesian optimization. And I'll just quickly show that how easy it is just to set up this kind of hyperparameter tuning, right? And you can use any kind of a framework. It doesn't have to be TensorFlow. You can use it for PyTorch or any other algorithm, as long as you follow some standards. And then it actually hides all of the complexity from the user. You don't have to code anything for hyperparameter tuning. You just focus on, this is my standard training code. As long as you are simply putting the logs in a certain template, you should be good to go. So here in this case, you can see in a quick example. So here what happens is, let's say that I have few parameters. For example, in this case, a learning rate, number of layers, and an optimizer. And you can define multiple hyperparameters. You can define their ranges, what are the things that you want to try it out. And then once you execute it, it will launch parallel experiments. So that means it doesn't have to be sequential. And then every experiment can be in itself be, let's say, take probably either on work on subset or probably work on large data sets. And every experiment can in fact spin off multiple nodes, multiple GPUs, all of that you can do based on your requirement, scaling requirement. But the good thing is that it also provides, you can actually compare multiple experiments. So it will give you very nice visualization. You can filter down. So for example, in this case, every line represents one particular experiment. And then you can say that, okay, give me all of the experiments which actually led to probably highest accuracy on validation data set. And then it will give you that, what is my learning rate, what is the number of layers, what is the optimizer that we used for that experiment, and you can proceed from that point in onwards, right? So this is what is Cative is. So again, Cative is again a community contribution. It was not part of the earlier Kubeflow. It was built, and so let me quickly show how easy it is to set it up. All right, so just give me a sec. So while this is opening, all you need to do in the hyperparameter tuning step is, again, just like we did, sorry. In the training job, it has to be a YAML file that you create. So I think I have it here. while this is opening up. Any questions so far?
Sorry, yeah, I think Abhishek, we have one question that I can just see right up in front of me. Is about how active is the Kubeflow community in terms like in terms of like, is it actively maintained by the community? How are people, do people contribute? Do people actually when you have questions, do you have answers? I mean, and how
Right.
fast is it growing? I mean,
Yeah, it has obviously a very flourishing community. So probably there are multiple, not only individuals, there are companies who are working in it, who are probably contributing to this. There are, so Google obviously is one of the core contributors, but apart from Google, Microsoft is involved, and then NVIDIA is involved probably, and there are other companies who are also contributing. There are a lot of other individual contributors as well. You can just go to Kubeflow GitHub link, since it is open source, and you can see that it is. And it is one of the most popular, at least from the ML development lifecycle perspective. Probably there are others which are maybe in a similar frame would be MLflow, which is by Databricks. So MLflow, Kubeflow, these are some of the probably open source frameworks which you can leverage for building the machine learning pipelines. Then all of the companies obviously have built their own. So for example, you might have heard Uber building their own framework, Michelangelo, Facebook build their own framework, FB Learner. But obviously,
right.
either a big company where you already have those things, or if you want to use something which is off the shelf available from the open source, you can look into this. So for now, I believe that this is, I believe, the most exhaustive framework out there, which kind of provides lots of components, and you can use that based on a requirement.
Yes,
Anyway,
yes, Abhishek. Yes,
so
Abhishek.
coming back, any other question?
Yeah, there are a couple of questions, but I think we'll take it up after this,
Sure.
after you once you
I'll quickly
complete your
go through it.
tutorial.
Sure. All
Yes.
right. So I was talking about distributed hyperparameter tuning, right? So all you do have to do is, in this case, is again create a YAML file, and all you need to do is provide it. Okay, you know what? I want, let's say, 3 parallel trials, or I want total 6 trials. You can change the numbers based on requirement, but essentially what you need to provide is what is your objective. So in this case, we are saying that take my model and then and try to maximize my validation accuracy, and your goal is to reach 0.9, right? While you're doing it, you also want to track some of the additional metrics such as loss and accuracy on the training data set. It could be anything else. And you can change, you can need to provide what is your algorithm. So it could be a random search. If you want to do a grid search, it could be a grid search. You can actually just do a Bayesian optimization, and that's all it takes to probably change it to a different optimization strategy. That's it, one liner. I'll just switch it back to random. And then you need to provide what are the hyperparameters that you want to tweak. Let's say that I want to do a learning rate between, let's say, 0.01 to 0.08. But you can have not only the double value, it could be integers, for example, number of layers, it could be anything, number of filters, it could be optimizer, which could be a categorical. So let's say that I want to use SGD, Adam, or any other optimizer. So this is what you call as that. What are things that you want to do during your hyperparameter tuning process? And then you need to provide what is your specification. So when you say a specification, that means is what happens when every experiment is executed. So in this case, what we want is whenever you are executing every experiment, it should kick off a distributed training job with, let's say, 1 chief and 2 worker, right? And then it will probably run all of that job. This time we are not saving the model. We are simply saving that what is the performance that we have got. So as you can see that this is the only file that you need to create. And again, once you no worries. All right. So I'm not sure from where I left, but I'll start from serving. Okay. Okay. Okay, sure, sure. All right. So probably I'll just quickly go back, and I was just talking through what you call as hyperparameter tuning and how you can leverage Catib. I'll not go into detail again, but a straightforward is that all you have to do is create a YAML file saying that what is your goal, probably let's say, and then what are the hyperparameters, and you can define either, let's say, any something floating values. You can have something which is an integer, and then you can define the range, mean, and max. You can also define your categorical variables that you want to use for your hyperparameter tuning. For example, I want to try out different optimizers such as GD, Atom, or any other. And then you have to define what is your blueprint for every experimentation. So in that case, what you define is, for example, you want that every experimentation consists of a distributed training job with, let's say, one chief and probably a couple of workers. And in this time, and then once it will train the model, it will spits out that what is the model performance. And then you can actually compare and contrast against other experimentation that might happen parallelly. And then you can again go back to your Cative interface, which will give you the comparison of across multiple trials. And then you see that, okay, which particular experiment gave you the best performance, right? So so far again, so the idea here is that, and you can also try it out different optimization algorithms. So for example, in this case, we are using a random search, for example, but you can easily switch to random from random to grid. You can have grid search, you can have more complicated such as Bayesian optimization, and you will have Bayesian optimization done. You can try out hyperband. So Catib supports probably multiple optimization algorithm, and you don't have to write any other code. So as you can see that there is no extra code that I have written. All I have to do is just create one YAML file and I'm done, right? So, and then you can switch between different algorithm and see that which algorithm works best for you. So this was about hyperparameter tuning. Let's probably switch back to probably some of the other stuff. So far you can think that, okay, we have done our initial experimentation. We learned about metadata component and how you can use metadata to track a different experimentation. We also learned about TF job and how you can use TF job to kick off a distributed training job. You can have multiple workers working for you. Every worker can have multiple GPUs as well if you want. And then we switched to hyperparameter tuning at scale, how you can do that in a production kind of environment where you're working on a large volume of data set, and how you can switch between different optimization algorithms if you want. But next step is, let's assume that after doing hyperparameter tuning, you have got the best model that you want. And then you want to take that model and then probably serve that. So that means is you want to open that for inference so that it can be used or consumed by other applications. Now, there are multiple options for doing that, and Kubeflow provides multiple options. If, for example, if straightforward, if you have a TensorFlow model, you can directly use TensorFlow serving, and obviously it will give you a low latency. You can directly use that. It will gives you lots of other components as well. The biggest benefit, I believe, is what we get in a Kubeflow world is what you call as a KF serving. So KF serving, you can think as a Kubeflow serving. What it provides a serverless inferencing. So what does it mean is you don't have to bother about, let's say, scaling up, scaling down. It can do all of that on its own. It can actually look into, let's say, you have 5 nodes, I have 10 pods or 10 replicas, and all of that it can configure. You can also use GPUs for your inferences. All you have to do is just configure that, and I quickly show that how easy it is. And then it can support any framework. So while TensorFlow serving you use if you have only TensorFlow model, KF serving you can use for any model. So for example, you have models in TensorFlow, you have models in scikit-learn, you have models in PyTorch, even ONNX format, XGBoost, anything that you can leverage. Then it provides some of the features out of the box. It gives you candidate releases, and I'll show that how easy it is. You can run your multi-arm banded A/B testing kind of a thing. It also gives you flexibility on the model explanation, so you can attach your explainer. So that means is not only you give a prediction, it also gives that what is the explanation for individual prediction. It comes with integration with the explanation framework called Alibi, and then you can use Alibi directly, and probably a couple of lines of code, and I'll quickly show how it is. And then you can also detect your outliers, biases, and everything. So let me quickly show, probably we don't have much time, but I will quickly show that how easy it is to set it up. So in a serving, in a very standard serving, what you need to do is you can create another YAML file, which again, since we are dealing with Kubernetes, is a standard YAML file. So in this case, all you need to do is simply provide, for example, in this case, what I'm providing is a specification where we're saying that I have a predictor, which is a TensorFlow model, and the model is stored in such location. In this case, it's a GCS location, but it can be an Azure location, it can be an AWS location, whatever it is. If you're running on a local, it could be a local location as well, right? And then that's all it takes, right? And then once you run the YAML file, your models will be exposed. It will be exposed as an endpoint. You will get an API endpoint. Everything is abstracted away, and it is as simple as that, right? So let me quickly see if is available. But in interest of time, I will not run. I'll cover some of the other things. But so this is how you probably expose your model. And like I mentioned, it will give you a service endpoint. But you can actually go beyond that. You can have more complicated serving requirement. So for example, one of the very common requirement that comes, which is you might want to do a transformation. So for example, you have built an image recognition model, right? But you cannot directly feed that model. Let's say that somebody is giving you image, which is a base 64 encoded image. And then you might have to, let's say, do scaling, right? You want to do that at grayscale, you want to normalize that, or you want to do some cropping and whatever it is. So you might have to apply certain kind of a pre-processing, right? Then you might also have requirement what you call as a post-processing. So for example, you built a image recognition system which gives you classify into one of the classes. But most of the model, what you will give it, will give you probabilities for different classes. But what you want, let's say, is what is the maximum or what is the majority of the class, right? Now, typically what you do is you create a wrapper layer, or probably you handle that into your core application, which is that I'll get my probabilities and then I will play around on those probabilities and identify the maximum, right? Or from your core application only, you perform a pre-processing. Now, this is fine for most of the cases. Sometimes it can be complicated where you don't want to probably know the end user to know that how exactly you want your model to be, probably do a pre-processing of your input data. So what you can do is you can attach what you call as a transformers. So transformer is, you can think that as anything which is taking your incoming input and then performing certain kind of a transformation. So transformation in this.
So I think if you could just give us an 1 minute once again, just I'm
Sure.
really sorry about this. So if you could just give us a minute. Yeah, Nishant. I think Nishant, you would take. Can you take over? Yeah. Done. I've stopped it from my side. I'm really sorry, Abhishek, about this.
No, that's fine.
Unfortunately, because of the internet connection, we're facing some issues. So Abhishek, while we go live, I mean, what else do we have to cover now?
Yeah, I think we are almost towards the end, and then probably
Okay.
I'll take your questions if that helps.
Right. Unfortunately, there's this problem with this connection today. Yeah, I'll just check it once. Just give me a second. I think what we have open is the code now. Abhishek, if you could just switch to some other slide or some PPT so that I can just get to know that okay, this is visible. Yeah, I can just see it. I think yeah, the KF serving. I think it will just take a minute or two before we go live. Guys, if you can hear me on YouTube, unfortunately we lost the connection. We really apologize for that. But we're just trying to go live again, and I think we're almost there. Just give us a second. Yeah, yeah. Yes, Abhishek, I can see the KF serving screen on YouTube now.
Okay.
Guys, we are back. We're really sorry for the inconvenience.
That's fine.
Yeah.
All right.
Yes.
So
yes,
can I get started then? I think I'll just wrap it up quickly.
Yes. Guys, if you have some more questions, please post it on our YouTube channel. Abhishek will be wrapping up the session shortly, and then we'll address all your questions. Okay, Abhishek.
All right. So probably I'm not sure where we left. So I was talking about serving. So we just talked about probably standard serving, and we saw that probably in order to make a serving, it's a pretty straightforward. All you have to do is specify, create a YAML file, provide that what kind of model it is, if it is TensorFlow model, if it is a PyTorch model, if it is a scikit-learn model, and then you simply provide where exactly your model is located. You also provide what you call as replicas. So what is here we are saying is that I want a minimum of one replica, but you can, and it will automatically scale. So that means whenever you launch this, there will be at least one pod. Essentially, you can think that as a box that is running, but it can automatically scale if required, right? And if you have time, I would have shown you that probably how it automatically scales up and down, but you can take my word for now, and it will automatically scale up to as many replicas as we want based on the number of requests that it is getting. You can also see all of that. It has integration with Prometheus. It has integration with Grafana. So that means you can see the dashboard and that how your performance is going on. So this was about very standard serving. You, like I mentioned, as in some more complicated requirement where you might have certain transformations required before you feed to the model prediction. That could be, let's say, some kind of an image processing that you want to do and some kind of a post processing that you want to do, right? And you can handle all of that stuff. So for example, here I'm just showing one example where I'm taking a raw image. So instead of NumPy array and whatnot, I can take a raw base64 encoded image directly from the command line or from an HTTP request. I can do all of any pre-processing logic I can apply, be it by maybe normalizing that, reshaping that. And once the pre-processing is done, it will feed for the prediction. You can also do a post-processing. And post-processing, again, it could be very standard, very complicated, or it could be very easy. In this case, I'm simply taking all of the probabilities and probably result like returning the actual class rather than the probability values. But it could be any more complicated stuff. You want to probably log that, you want to send emails and whatnot, right? So all of those logics that you can apply inside your transformation. And then again, you bundle all of your transformation inside again in a container. So again, containers are coming again and again. So in this case, again, very simple container that we're building, which is taking from Python, installing some of the required dependencies, and running a container which runs the transformation logic. And once you have built the transformation layer, then what you do is in a YAML file, you also attach what you call as a transformer. So you're saying that this is your core predictor. So use that predictor, which is take the models from this location and then expose that as an endpoint. And then any input that is coming, it will go through the transformation process, both from the pre-processing as well as the post-processing. So this is about processing. You can another thing that it is also very much required, what you call as canary releases. So what is canary release? So think like that. So you have built a model. And there is a person in your team or probably on a newer team has come up with a newer version of your model, and they claim that this is great, right? But in a typical production setup, you don't want to simply disturb your previous settings or previous model because somebody claims that, right? You also want to test it out, right? So, but you don't want to take the risk that I want to simply replace all of the newer traffic to the newer model because you don't know how it will respond to the newer model in a real world setup. So what you do is, again, this is a very common practice in enterprises, what you call as a canary releases. So think like that. So let's say that instead of 100% of the traffic, I'll take only 5% of the traffic incoming request to your prediction request and then pass it on to the newer version of your model. And then in the backend, I can track the performance. And if you feel that this model is good enough, then we slowly increase from 5% to 10% to 15% to 50% and eventually to 100%. So all we can do probably just a couple of line of code, which is, for example, here is my default. For example, this is my default model, which takes one version of your model. And then you can also have another version of a model, which is your canary version. And it could be altogether a different location. And then you need to provide what is your traffic percentage. So in this case, I'm saying 50%. That means any incoming request which is coming for a prediction to your API, 50% will go to the newer model, 50% will go to your older model. And you can change the number, whatever it is, and then redeploy that, and it will automatically change your production. Suppose, for example, now you're done with probably model is working great, and I want to directly switch completely to the newer model. All I have to do is simply change my canary traffic percentage to 100 and then redeploy, and then you are good to go. Right. So this is about canary releases. You can also, let's make it 50 and compare against two versions of your model, run A/B test on all of that, right? And internally it will handle all of that routing and everything. So internally it uses Istio, so you don't have to know about those. But probably if you want to make probably more complicated logics, you can actually build your Istio rules. There are probably more stuffs probably I would like to cover, but just to give you a flavor that it supports lots of monitoring framework. So for example, you can integrate it with Grafana, which will give you a dashboard. You can integrate it with Prometheus. Probably you can integrate it with other things as well, like put into Elasticsearch and whatnot. It also provides all of the auto scaling out of the box, so you don't have to do anything. Probably you can run your load testing. So since we don't have time, but maybe you can go through the course and go through it. But you can run a standard load test. For example, in this case, here I'm just trying to run a load test with 5 simultaneous users, or maybe creating 50 query per second inputs to the endpoint. And you can see that the number of pods running your actual serving will actually increase automatically. And then after some time, if you are not getting any requests, it will automatically come down as well. So it supports both auto scaling up as well as down. So this was about probably serving. But at the end of the day, you'd like to probably combine all of the steps into what you call as a pipeline. So pipeline is something where you simply combine all of the steps, and you can build a very complicated pipeline. I don't want to probably go to building pipeline right now. That could be a topic in itself. If you are interested, do drop a note and maybe we can cover an entire session on that. But I'll just quickly show that probably you can have a very complicated pipeline to very simple pipeline. For example, I'm just showing a couple of examples here. So in this case, one pipeline which actually uses TensorFlow extended, but it could be very simple. If you have a TensorFlow, let's say scikit-learn, you can build that pipeline as well. But eventually every box or every step in the pipeline, you can think that as one container or one box. And then you can probably link multiple boxes and come up with build your own complicated pipeline. You can actually run these pipeline with, for example, with certain what you call as a timeline. So for example, I want to train my model probably every weekly, bi-weekly. You can schedule all of your jobs, track all of your jobs, all of that you can try it out. So probably again, so a lot of things to cover. It's a very massive framework. It supports, it provides a lot of features. We cannot cover everything, but hopefully it might have given you a sense that probably what are the things that you can try it out. Again, if you want to probably look into some of the other things, you can go to kubeflow.org and set it up either on cloud, either on locally, try out different like examples, tutorials, blog posts are there, some YouTube videos are also available. If you're looking for full-fledged course, then probably you can check out my course. You can try out a free trial and you can go through it. So here is the link, bit.ly. I think if you can paste it on the chat box, and you can go through the entire course, which is roughly 4.5 hours. So I'll take a pause here and take any questions if you have, and we can go it from there.
Yes, Abhishek. Thank you so much. Thank you so much for this insightful session. I mean, I personally enjoyed it a lot. I mean, this was very insightful for me as well. And I think even the audience would has the same thing to say. I mean, they've learned it a lot. I think Nishant will fire us with a few questions. Will
Sure.
take up the questions that are there. Nishant, you can you hear me? Am
Yes,
I
yes,
visible?
yes, Nikhil.
Am I
Yes.
audible? Audible. Sorry.
Yeah, you are
So
audible.
before that, Abhishek, I would like to ask you something.
Yeah.
Like for people who want to break into machine learning or the deep learning field, like probably as freshers or someone like supposingly I'm a fresher, I just want to get into the industry, I want a role related to ML or DL,
Hmm.
or be it someone who's been in the industry for a year or two and they're looking for a change in career, they want to get into this field now. So
Hmm.
I mean, there's one part that you take up some courses and you learn things and
Yeah.
then you build some projects.
Yeah.
But how does it differ as per your experience and your opinion? Does it differ from the recruitment perspective if you have something deployed,
Right.
like you did in the course?
Yeah.
Because there's something
So
as students, we build some projects, some
yeah.
hobby projects or something out of related out of courses, but just building up full scale model that how would that change it if you were the recruiter or from your
Yeah.
perspective?
Yeah. Sure. So I think so. Good question and valid question. So I have been interviewing probably folks since ages and from campuses and all other places as well. While obviously, at least personally, I don't expect probably freshers to know all of that bit in detail because it's not possible. Because some of these things, once you get into in projects and actual engagements and actual live projects, you have to deal with either way, right? So probably it comes with experience. But having a knowledge of that, what it takes, it's definitely is brownie point, I'll say, if not probably
Right.
the most important bit. Because as long as are comfortable with probably how it works out. In fact, nowadays, if you see that with the advent of all of the frameworks and out there, actually it makes probably a couple of lines and you can run model.fit and probably you can use pre-trained models and whatnot are available. So that makes the development process very easy. But it is not translating into actual uses of these models into industries. So that's the
Right.
reason all of these things are getting popular, especially in the last couple of years. A lot of focus is have happened in this particular area, and a lot of companies are pumping money into this because this is one of the crucial facets which will actually provide a like differentiating factor between candidates, between organizations, between projects and whatnot. So
Right.
definitely it is something worth exploring, and you might not have like, okay, since you might not have, let's say, cloud infrastructure or probably, but you can obviously play with locally. Maybe you can try to set up probably with free credits and whatnot, especially for students. People who are, let's say, 1 or 2 years of experience, definitely they need to understand that
Ab-
how these
Abhishek,
probably
Abhi-
entire things probably work together. Sure.
right. Abhishek, I think it's showing a notification change the battery pack. So sorry to interrupt you on your system.
Sure.
I think the
Okay,
battery
so
is getting discharged if I'm not
let
wrong.
me just
Yes,
quickly
Abhishek. Thanks.
stop
Yeah. Yes.
video
Yeah.
and
You
then
can just. Yes. You can. Yes. 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 Yes.
all
Yes,
right.
Abhishek.
So any other question?
Yes. Right.
Yes,
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 Nishant, if you
Abhishek.
can
Yes,
just
yeah,
fire a few questions. And
yeah,
Abhishek,
sure.
thank you for answering that question so perfectly. I mean, thank you for answering the question so perfectly. Thank you. Nishant?
Yeah. So if I'm not wrong, Abhishek have answered this question, right? Is Kubeflow actively maintained by the community, right? So we will take
Yeah.
the
Yeah.
question after this. So Anubhav is asking, does Kubeflow has payload logging in product?
Sorry, I didn't get the question.
Does Kubeflow has payload logging in PROD
Right.
prod? Yeah.
So you can log anything, right? So probably you can do anything with probably. So essentially, you can think like Kubeflow is nothing which is nothing extraordinary. It is providing. It is probably a wrapper of multiple packages, multiple frameworks which are already out there. It kind of combines multiple things into one ecosystem which works together, right? That's the whole value proposition behind Kubeflow. So anything that you have, if you and probably a lot of companies are running these things into production, including Google and others. So and you can track and log and monitor everything that you want, if that answers.
Okay. Yeah.
Right,
Thanks,
right.
Abhishek. So the next question is, where is the spec for transformer resource type and how many different resource types are there and does Kubeflow doc cover them? Does these resource type differ from deep learning? And can we have Knative with Kubeflow by any chance? Like it's a long
Yeah.
question.
Right. So if you see that Knative is already there. So for example, Cave serving actually under the hood actually uses Knative. So and when it deploys all of that required underlying layer as well. Probably some of the companies have it's a separate instance, so you can have your own, and or you can deploy along with it. So you can do all of those mix and match. You can have let's say your own Istio. You can have all of those layers as well. So that means to answer the question, yes. In terms of specifications, so because these are all custom resource definitions, there are a lot of custom resource definitions which are already there. You can leverage that, and all of those informations are available on official Kubeflow documentation or in code. So some of the documentation might not be there, but definitely they are in the actual code. So you can look into their GitHub repo, and you can look into what are the things you can try it out. What was another question? Transformation also. What was the question?
Yes,
Sorry.
yes. I will repeat
Yeah.
the question. I will repeat the question. So the question was, where is the spec for transformer resource type and how many different resource types are there, and does Kubeflow doc cover them? And does
Yeah.
these resource type
So
differ from deep learning?
right. So it's like I mentioned, is KF serving, which actually has like you can define transformers and all. It is the API is uniform, and you can have let's say any kind of a model, right? So in this case, I use a TensorFlow model, but you can switch to any other model, be it scikit-learn, be it XGBoot. There will be minor changes, and then specification. You can go to the documentation and see that what are the types that you need to place. If you have a specific model, you can have completely custom model as well. So I shown a TensorFlow model, but you can have a completely custom model where you can create your own packages, which is either neither of TensorFlow, neither of scikit-learn. Might be you might have built your own model on whatnot. Let's say using some of let's say OpenAI, Hugging Face, and whatnot. So you can build all of those. So just go to your Kubeflow KF serving page on GitHub, and then go to some examples. You can identify which examples mimics your situation.
Okay, thanks, Abhishek. So next question is from Anubhav. He's asking for the explainability component. Does it have capabilities to explain transformer models?
Okay, so currently the KF serving it actually uses Alibi explainer. So let me just see if. So currently the KF serving is your which supports a few of the algorithms, so you can look into. So this is an Alibi explain, and it supports few of the machine learning standard machine learning models as well as. So for example, here you can see that classification, some of the images, text, all of those that you can try it out. So if you want to know more details about it, you can look into the examples, and here are the bunch of explainability frameworks which are already included. Okay.
Okay, thanks,
So
Abhishek.
it's probably it's not that exhaustive, but I think it probably works for most of the cases, I believe. And you can have like say Keras models and whatnot.
Okay, thanks, Abhishek. Now we have the last question, which is from Rangaswamy. He is asking,
Mm-hmm.
is pipelines the complete end-to-end service endpoint?
Right. So typically your pipeline will have, it depends on what you want to make, right? So your pipeline could be very simple where you are doing a simple batch training, or it can be as complicated where you are building from development training to serving. So it's up to you that what you want to build. Here in this example, it's let's say a more complicated model like pipeline where from data pre-processing to validation to endpoint generation, but you can have more simpler pipeline as well. People have built as complicated as it can be. So for example, this is a pipeline which uses SG Boost, and it uses data proc cluster. So where these are data running using Spark, and you can mix and match, right? It's up to us that what you want to do. If it is just an offline evaluation, you can do that, and maybe your end result is just to get an ROC curve or confusion matrix. For some example, it could be exposing that as an endpoint, which can be consumed by other applications. So nobody is stopping you to build whatever pipeline that you want to.
Okay, thanks, Abhishek. We are done with Q&A. We don't
Okay.
have any other questions.
Yes, Abhishek. Abhishek, once again, thank you so much for taking out your time on a Sunday and addressing our audience and giving them such a good introduction and explanation. Not just an introduction, but a good detailed explanation about what Kubeflow is and how they can use it and how they can learn more. Thank you so much, Abhishek. And I would also like to thank Nishant for helping us with the streaming today, for and taking up the Q and A's and all of this. Abhishek, thank you so much. Thank you so much once again. Really appreciate it.
Thanks a
And
lot, Nikhil, and thanks a lot, Nishant, for all the hard work.
thank you, Abhishek. Abhishek, if they want some like some more resources, is there a way? There's something that we could provide in the link for
Yeah,
the
so
folks
I'll
that want
provide
more resources.
the deck link probably just
Right,
afterwards, and you can just post it on the channel if that helps.
right, right. Right. That helps. That absolutely helps. And to our wonderful audience, thank you so much. We know it's a Sunday and you took out all your time and interest for this amazing session by Abhishek. So thank you so much. If you have any questions, I mean, you can just post it. We can post it on a channel. If you want to connect to Abhishek, his LinkedIn URL is there in a description for this event. You can connect with him over there. So yeah, that would be all for today from GDG Bangalore and Abhishek and Nishant and me and my team. Thank you so much for for being tuned with us. Thank you so much once again.
Thank you.
Thank you,
Thank you.
Abhishek.
Thank
Thank you,
you.
Nikhil.
Thank
Thank you.